Hi, this is Miss Linton, and yay, we have a quiz. So chapter 31 and chapter 33. Chapter 31 is very minimally about homeostasis. And so, did I hit record? Oh, yeah, I did. Okay. Oh, say hi. Hi. All right. So in chapter 31, you don't need to worry about the different types of connective tissue or anything like that. I'm just going to focus here. Whoa. Keep going. There we go. Homeostasis. Okay. So for homeostasis, we need to remember that there are two big systems that contribute, nervous and endocrine. Who works faster? Nervous system works faster. Good. And we'd already talked about negative feedback. And don't think of negative like a bad thing. Negative is just, it controls the level of something. It keeps it about the same, keeps the continuity of that. Whereas positive feedback, you're going to keep going up until you have some climactic event like a baby. Okay? So negative feedback, we can think of that like setting your cruise control and you'll just hover right around 65. You want to have a certain level of glucose in your body. You don't want it to be too low and you don't want it to be too high. Eating your Halloween candy, you could go into a seizure either way. Positive feedback is where it keeps going. Those are all my students having babies. And then they were pushing out the baby. And then you end up having that baby coming out. All right. So that's feedback. We're going to move on to the immune system. Okay. Now, we looked at a couple big themes here. One theme, remember, the immune system is not mandated for your APBio exam. But we could look at it from the lens of evolution and how the immune system evolved. And we looked at it from as simple as slime molds what do I want to say? Yeah, slime molds. And they will live. What do you want to say? I don't know, Miss Lynn. They can live as unicellular or they can live as multicellular organisms. And when times are tough and when they're in multicellular organisms, they have specific cells that go and patrol their body to make sure that they don't have any pathogens. And maybe that was the beginnings of an immune system. We talked about different kinds of molecular patterns that you could find on a pathogens. We call those PAMPs. And then we have what? Receptors. Now, fast forward, because when I first taught you that, you didn't know about T cells and you didn't know about B cells. You didn't know about macrophages or anything like that. Now you can see that they have receptors, right? So that they can communicate one cell with another. So we looked at cell signaling could be very simple, like we see here, with different kinds of PAMPs triggering a reaction in order for this plant cell to defend itself. But in reality, it's a very, very complex process, cell signaling. So you have some sort of message, you have some sort of receptor, then you have signal transduction, and then you have some sort of product or change that you have in that cell as a result of that cell signaling. Okay, the next big ticket thing we discussed, when we want to talk about the immune system, we have to address your circulatory system. And to address your circulatory system, we need to know the different vessels. So let's review that really quick. Arteries go away from your heart, veins go towards. Arteries, arterioles, capillaries in the middle, venules, veins. And the reason we go like this is because that's where all what takes place? Exchange. Okay? So at the arterial end, and I'm referring to your systemic circuit here, not your pulmonary, not your heart, lungs, heart. I'm talking heart, body, heart is your systemic circuit. Your arterial pressure is going to be greater than your venual pressure in your systemic circuit. It's the other way around in your pulmonary circuit. Okay? Because arteries go what? Away. Okay, so any vessel that's going away from your heart, an artery, is going to be under greater pressure. Okay, so when I need to correct myself, sorry, I'm tired. In your systemic circuit, arteries always will have greater pressure and always have greater pressure in your pulmonary circuit as well. but which ones carry the oxygenated blood? In your systemic circuit, arteries carry oxygenated blood. In your pulmonary circuit, your venules carry your oxygenated blood because you're coming back from your lungs back towards the heart. Did I get you on that? You okay? Arteries always have more pressure than venules. Arteries always have more pressure than venules. So at the exchange, here they have the arteries on the right. The arteries are going to, the fluid's going to have greater hydrostatic pressure. It's going to be pushing fluid out into your cells. Your cells are going to be, yay, oxygen, yay, nutrients. And they're going to give back CO2 and waste. And that should get picked up due to osmotic pressure back here at the venule end. But if more gets pushed out to the cells than gets reabsorbed, you'll have some leftover. And remember, we talked about leftover, you could have an edema. So we don't want that to happen. So your lymphatic system will pick up the excess tissue fluid and return it to your circulatory system at your subclavian veins. But before they return it, they will pass it through a lymph node. And that's where your policemen and your special forces can hang out. Because anything that's out there in the body, that's out there in the tissue fluid, it's going to get picked up and it's going to have to go through that checkpoint of a lymph node. And so you can just patrol the lymph nodes, and in essence, you're patrolling the entire body by doing that. Okay, so your lymphatic system is very extensive, and it's one of its job then is to absorb that excess tissue fluid like we just talked about. The job that most people forget about is this one. It absorbs fat at your intestines. And the third job is to produce lymphocytes. Who are the lymphocytes? Yes. T cells and B cells. And there's a third one. He's the dropout. Yeah, the natural killer cells, because they dropped out of the school of thymus, so they were supposed to be lymphatic, but they bailed. Okay? So those are your three jobs. So then we talked about the primary organs of the lymphatic system. We talked about your bone marrow. All blood cells will come from your bone marrow. All blood cells will come from your bone marrow. B cells come from there, T cells, anything in your blood comes from your bone marrow. The B cells are called B cells because they actually mature in your bone marrow. That is where they mature. Your T cells migrate to your thymus gland, and it's on a little girl, and that's because it is larger when you're a child, and then it atrophies because you've already learned self from non-self. Yeah. And your T cells will mature in the thymus gland. Okay? Your lymph nodes and your spleen do the same thing. They're checking and processing for your fluids. In the spleen, they're processing blood. In your lymph nodes, it's lymph fluid or lymphatic fluid, checking to see if there's any pathogens in them. You have some other lymphatic organs as well. We talked about the spleen. Okay? which I already talked to you about. We talked about in your digestive system. We talked about in your tonsils, right? This is all lymphatic tissue. Now, we know what the players are, so our next job is how do we go about it? So you want to think of it first is you would rather not have any war at all, right? You would rather negotiate and not have any kind of battle. So the way we do that is we have something to keep all pathogens out. What do we call that? Skin. That's our number one barrier, okay? To keep things out of our body is our skin. But we don't want to have cracks in our skin. That's why we have oil glands, is to keep our skin flexible. But there are places where I don't have thick skin, dermal layers, like in my mouth, right? And in the membranes of your nostrils and in the alveoli, in your stomach, you're putting things in and they could cross those barriers. So we have different things like hairs, antimicrobial agents in our mouth. We have a low pH in our stomach. We have antimicrobial agents in our tears as well to help protect us about things trying to enter our body. But if something does get in our body, how do we know it doesn't belong to us? We have receptors, but what are we receiving? Yes, but what do we call them? It starts with an A. Antigens. There you go. Yeah, antigens. I like it. Make it an effort. Okay, so those antigens are things that could trigger an immune response. Do our own antigens ever trigger an immune response in our body? Yes, that's exactly what I was after. That's called an autoimmune disease. That's not a good thing. That's when we start to attack our own self. So it should not trigger any immune response in our body, okay? But you have these on every single cell. Every single virus has them. But in our own self, we have learned that belongs to me. I don't need to fight it or attack it. So then if I do need to attack, I have two groups. I have my innate immune response, which is like my police force, and then I have my special forces. Okay? If all I have is my innate immune response, remember, it can overcome and overtake me, and I could end up dying from that particular disease. I need to eventually elicit my special forces. Now, let's just run through quickly what some of these things can do. What do mast cells do? Secrete histamine. Dendritic cells? Eat things. They're like the garbage man, and they like to present things like, hey, I killed this. Anybody recognize it? They look for virgins, right? Okay. Macrophages? Eat. But they don't start out as macrophages. Remember, they start off as, do you remember what they start off as? Monocytes. And they're smaller so they can get out of a capillary, and then they enlarge, and they're very, very long lasting. Natural killer cells kill. Basophils, eosinophils, and neutrophils are all collectively called granulocytes. What's the most prolific of those? Neutrophils. Basophils are in your blood. Eosinophils go for the big ticket items like a worm or like a splinter or something like that. And then complement proteins, remember CD4, CD, synthase, and eventually you drill a hole. But it could also be some other kind of like cytokine that amps up your immune response so that you fight better. Okay, special forces, two big categories, B cells and T cells. They are two strategies, very effective to wipe out any kind of pathogen. Okay, one is actually like the, who are the guys that are the first on the scene? Why can't I think of their names? In a battle. No, in a war. I'm not going to think of it. They ride in ships and they land. Marines! Sorry, it took a minute. Marines are usually the first on the scene. And they do cell-to-cell combat. Which one of these guys do cell-to-cell combat? T cells do cell-to-cell combat. Who are they killing? Our own cells. Okay, they're like, I know you, but I got to kill you. I know you, but I got to kill you. Why would I kill my friends? They're harboring terrorists. They're infected. How do I know that they're harboring terrorists and I need to kill my friends? They're displaying an antigen on an MHC1. Okay? Other friends, I will help. And I'll be like, you fight. You go, girl. You fight that battle. Why am I helping her? She's displaying the antigen on an MHC2, which means she has overcome it. She's bragging about it, looking for help on that. Okay? All right? B cells do not go to the scene. They're not like Marines. They are like Air Force. And they are dropping their antibodies. But their antibodies are not bombs like what the Air Force would drop. Their antibodies just what? Mark them for destruction. They mark them for destruction so that they will get taken care of. Okay? We talked about the inflammatory response. So this is that response which amps up the local wherever we have that infection. We said mast cells secrete what? Histamine. And histamine makes our capillaries more so that the other fighters can get out. Whatever fighters you need there, they can get out a little more readily. If we have allergies, we take antihistamines. Here's a neutrophil, the most prolific of the granulocytes coming out here and eating. A dendritic cell would get here eventually. Here's a macrophage releasing cytokines. This is the alarm. He's saying, watch out. He's probably secreting like an interleukin. Interleukins pump up your whole immune response. As opposed to an interferon. They, the infected ones, they could be secreting interferons, warning the rest of you, we are infected by a virus, save yourself, so that you're more careful about what enters your cell. So think interferon, like I'm interfering with that virus life cycle, I'm interfering with what that virus want to do. Interleukin, I'm pumping up my leukocytes, my white blood cells. I'm going, Luke, Father. I don't know. You're saying Luke, fight. I don't know. I can't think of anything. All right. We talked about the complement system drilling holes. We talked about natural killer cells and how they go and they can obliterate. They can do it through apoptosis-like mechanisms or straight cytolysis, where they just like sending a machine gun around them, just killing anything that is around them. All right. Let's go back. Let's look at this. Get your bearings there. Is there anything scary on that? Ask your bio buddy. Anything scary on that to you? I put these in your notes already, this exact picture. Why is this called adaptive? Adapt to what? The environment that you're in, the pathogens you've been exposed to, right? The more you've traveled, the longer you've lived, the more antigens you're exposed to, the more of an immunological, you have less non-virgins. You have more people ready to go right off the bat to fight the battle even faster, and then you won't get sick again. Okay, so that's why you would call it adaptive. Comparison of the two. Okay, ask your bio buddy, are you good with that? Do you understand the different targets? What specific kind of cell releases antibodies? It is a B cell, but say its name. What is the specific cell, the specific type of B cell that releases antibodies? Do you remember? Plasma. Okay? Let's walk through this real quick because I think we might struggle a little bit. Remember, here comes along a dendritic cell. He eats anything. If it doesn't belong there, he eats it. Engulf, 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 eat, display, 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 inappropriately, okay? Here is a virgin T cell. He's like, thank you very much, okay? I recognize that antigen. Any other T cell wouldn't have recognized it. He's the only one who would have recognized that. Now you have a stimulated T cell, okay? Notice a T cell has to be shown the antigen on either an MHC1 or on an MHC2. If the pathogen could be crawling all over a virgin T cell, and he'd be like, what? Okay? That would not stimulate a T cell. T cell needs it displayed on an MHC1 or on an MHC2. All right? And then here is B cell. Notice there's 3 pathogens around him, but only this guy is one he recognizes. He's the only B cell who would recognize that. So now that newly stimulated B cell and that stimulated T cell, they get together and they say, I think it's a bad guy. Do you think it's a bad guy? Yeah. Yes. So let's make clone armies. You make clones of yourself and I'll make clones of myself and we will wipe it out, okay? Okay. And so she is going to, if she were a B cell, she would make 2 kinds of cells, primarily plasma cells, and it's plasma cells that secrete all the antibodies. But she would also make a few memory cells for next time. I'm a T cell. I will make some memory cells, but I will also make some cytotoxic T cells, and I'll make some helper T cells. Okay? All of our plasma cells and all of our helper and cytotoxic T cell, when the battle is over, will commit. And the only ones remaining will be our memory cells. So we will have a faster response the next time, and maybe we won't get sick. Because this whole coordination thing, where I had to get displayed on an MHC2, and she needed to come in contact with the pathogen, and we needed to hook up and talk about it, and make a decision about making our clone army, that will take 7 to 10 days. And that's why you get sick. But if you get vaccinated and you do the whole thing against a pathogen that's not actually going to hurt you and make all your memory cells, when memory cells come in contact with the pathogen, they're stimulated like this. All of a sudden you have that clone army will build up so rapidly so that you will not get sick from that infection. Okay? Those antibodies, remember, have 2 arms. So they can hang on to 2 bad guys at the same time. The base of the Y determines how you will be destroyed. Maybe a macrophage will eat you. Maybe you will implant your antibody into a mast cell so it will start secreting what? Histamine. Good. Okay? Remember, T cells. If you want to call up a T cell, you have to display an antigen to it, either on an MHC1 or on an MHC2. You got it. Okay. So take a look at this. This would be like more application. I did not do this one in class. Why do T and B cells ignore this? Let's start with T cells. Why would T cells ignore that? There's nothing in its MHC. Okay, so you have to display something in the MHC to have a T cell respond to you. Why would a B cell ignore this? It doesn't respond to MHC. It responds directly to the pathogen. Yeah. That's what will stimulate a B cell response. Obviously, this would be much, much smaller in, context to this eukaryotic cell. Do you agree? You okay with that? It should be smaller. Okay. Why would this start? Yeah, the antigen is displayed on an MHC2. B cells are like what? Okay. They need to be exposed to the real deal. Okay. Ask your bio buddy if you have questions on that slide. I haven't shown you that before. Okay, let me show you another one. Here are the invaders. They're apparently cooks. Okay, they're very bad. Look, he's drinking. He has a club. He's just mean. Here's this. This is a what? Antigen what? Presenting cell. Now, you would need the pathogen directly to stimulate a B cell. You would need the antigen presenting cell to show it to the T cell on MHC2. Good. Now, this B cell is activated. Releasing his what? Antibodies. Now, this model is a little bit deceptive because the antibodies won't hurt them. They will just mark them for destruction. Okay? And so here's an infected body cell with viruses or a parasite or some bacteria. He's apparently the chicken leg bacteria. I don't know what he is. These viruses are very happy and incredibly large. Okay? Notice right here, you have some leukocytes attacking the worm. And I labeled him. That would be an eosinophil. Remember I said some go for the big ticket items. That's what they do. Look what's going on here. This T cell is doing cell-to-cell combat with one of its own body cells that is infected by a really large virus. Okay? And this antigen presenting cell wants to eat him and display some, and the B cell is dropping antibodies. Okay? Here is also, I think I showed this in some classes. I can't remember. This is like a little summary of everything. Be helpful. I think it might be in your notes though. Is it? I don't know. Okay, and then got it? Okay. Then remember the Venn diagram kind of breaks things down. What do they have in common? They have in common what? Memory cells. T cell, they target our own infected body cells, either with helper, you go, captain of the response, cytotoxic T cells killing. B cells, they target the actual bacteria, toxin, virus by releasing antibodies to mark that pathogen for destruction. Yes?
So how do the cytotoxic B cells kill the cell?
They can bind with it and then literally release like a little bomb inside that cell. Like a little enzymatic bomb. Okay? Now, I heard a kitty. All right. If you take a little bit of time in your book, it'll show you pictures like this where you can study it better. It shows you non-specific defenses versus specific. So there are pictures. It's just hard for me to show you in this one little screen. But I put this in your group shared notes. It also is a little summary of everything that goes on. I put that in your notes. Okay, next. Immunity. First thing we need to remember is there's innate, you're born with it. That's your police force, your granulocytes, your dendritic cells, your mast cells, your complement system. Everybody's born with that. Acquired, if you have active antibodies. If you have active antibodies, that means you have what kind of cells? Memory cells. You have memory cells. If you have active immunity, you have memory cells. You could have those memory cells because you got them you got vaccinated with a weakened version of that pathogen, which gave you time, talk to my friend, yes, okay, to build up memory cells, or I actually got sick from it. Somebody got me sick, and now I have acquired that immunity. Okay? If you have passive immunity, this is not long-term, this is what? Short-term. Just as long as this baby is nursing, it will have its mother's antibodies. So its mother's antibodies, it doesn't have any memory cells, but this baby has a way to tag things that are foreign so that any immune system will come and fight and kill it. Okay, it identifies any bad guy that the mom has antibodies for. Okay, that will get passed through her blood. Or you get a quick shot of antibodies for a specific pathogen that you were exposed to, and you do not want to die from that pathogen. So you get a shot of antibodies, boom, so you can mark that particular pathogen, not because you have the memory for it, but because you borrowed those antibodies. Okay, so that would be passive. This is something I didn't show in class, but your first exposure to it, virgin B cells releasing antibodies when they're stimulated the first time, look at how high their antibody titer level is, how many antibodies they have. Look what happens on the second exposure. So those of you who have had to go to a country where you had to get shots, you had to get a first set of shots, and then later you had to get a second set of shots, that's so your antibody level would be pumped up. Because upon second exposure, your antibody level is even higher. Does that make sense? Okay. Cytokines I talked to you about, chemical communication. Interferon is I'm infected, protect yourself. Remember, I had to kill them, but maybe before I kill them, they release the interferon signal, a little homing beacon says watch out, protect yourself. Or interleukins, which is fight on. You could think of interleukin as being on the offense and interferon as being on the defense. Explain that to your neighbor. Why would I have said that? Interleukin is offense, interferon is defense. Okay, and then when our immune system is pretty flippin' amazing, okay? Knowing self from non-self and learning how to defend ourselves and adapting to the different environments that we are in. But sometimes it can do us dirty, right? So, for instance, being allergic to bees, being allergic to peanuts, being allergic to plant sperm, right? Plant sperm's not going to hurt you, but you can sneeze and get watery eyes because you have what kind of cells? They remember that plant sperm. They've seen that plant sperm before, and now they're super pissed about it. And you know what? Next time they're going to be what? Super, super pissed about it. Are you guys okay? Yeah. What? What? And so your response will be even greater, and could send you into anaphylactic shock if it's too great. That's when you need an EpiPen because your blood pressure will drop so rapidly, and you need the EpiPen so you can pump up your adrenaline. Basically, it's a shot of adrenaline so that your heart will beat faster and harder because your blood pressure is dropping. We talked about blood. Oh, we also talked about rashes that you can get from earrings or poison oak or poison ivy or cheap jewelry. Okay, red blood cells. Okay, you can give blood to anybody that you will not piss off with your blood. And you can receive blood from anybody that doesn't what? Piss you off. Exactly, okay? So when we think about what can make them angry, type A blood is labeled with A antigens, B with B. A and B blood does not have an amalgamation. It has some A antigens and it has some B antigens. Type O has none, okay? But O negative means it doesn't have A, it doesn't have B, and it doesn't have the RH antigen. AB positive, you can give it any old blood, right? You can give it A or B, positive or negative, AB positive, AB negative. Since it has all the blood antigens, it will not reject any blood. It will not be angry at any blood. It will not be pissed at any blood. Okay? And honest engine, though, you could give anybody any blood one time, and it would not probably, because there are no what? They could survive. But it would really be the second time. Okay? And where this has come to play in the past is when women are pregnant, and they're pregnant with a baby who has different antibodies or different blood type than themselves. What happens is in the birth process, which is painful and difficult, so don't, okay? Not now, okay? But in the birthing process, some of the baby's blood could mix with some of your blood, and at that point, if, let's say, you're type A and your baby's type B, all of a sudden now you're like, oh, B blood, and you will start talking, and you will make what? Memory cells, and you will have antibodies. So it's not the first pregnancy that could cause me problem, it's the second time you have a baby in you with B blood. You already have the antibodies will cross the placenta, and they will actually coagulate the blood inside the baby and kill the baby and cause a miscarriage. I knew a lady who had her first child, and her next 3 were miscarriages due to that, and her 4th one lived because it had different blood. Now what they do, it's not like a crapshoot anymore. Now what they do, as soon as you have your baby, they check your baby's blood to see if it's different. If it's different from yours in a way that could cause an immunological response by your body, they will suppress your immune system immediately with shots and keep you in the hospital 1 day extra. Does that make sense? In order to prevent something happening to your next child. Okay? All right. It can also cause problems during transfusions and tissue rejection. So you would have to take immunosuppressant. Okay. You don't want me to... There it is. So you would have to take immunosuppressants. And then we talked about autoimmune diseases as well, where you attack your own self. And I have some questions here. If you would like to participate, I'm going to pause you just for a minute while we log in. Okay, here we go. Okay, there's 3 questions. I'm going to just show them quickly up here while you're answering. Here is question 1. So try to answer that at home. Pause the video if you need to. Here is question 2. I think I have some other questions too after these that I didn't ask you earlier. And here is question 3. I gave you a way to remember that. Yeah, I have a few other questions I can ask if you want. You ready? All right, here we go. Okay. Come back to me. Shh. Vaccines. It is active. It is active because you will get to the point where you have your own memory cells as being exposed to it, and it is long lasting. What would be an example of passive immunity? Breast milk or the shot, gamma globulin shots. Okay. Number 2, a person with AB type blood could receive from which of the following blood types? Any of them. Remember? I didn't put in the positive and the negative there, but you could receive from any of them. And number 3, mast cell secretion combines with IgE. Do you remember how I told you to remember that? E2. You're sneezing. All right. Here's another one. I think I didn't ask you these. I think. I'm going to pause you just for a minute. Okay, here I'm going to show you the questions. Here is question 1. Remember, pause it if you need to think for a minute, because I'm going to move quickly through it. Here is question 2. Here is question 3. And question 4. Oh, there is no picture, but you don't need it to answer the question. question. The picture is superfluous. Everything is given in the question. It is superfluous. You ready? Because the bell's ringing. Raise your hand if you want more time. Okay, now, here we go. Okay, guys, quickly, I'm going to go through these for the people at home who might need help. Which applies to T cells? They mature in the thymus gland. They do not mature in the bone marrow. Who matures in the bone marrow? B cells. B cells. They do not mature. Yeah, okay. Number 2, antibody-mediated is most directly associated with B cells, not T cells. Plasma cells are B cells that are actively secreting antibodies. They are not the same as memory cells. They are not formed from blood plasma, and they're not inactive T cells. And number 4, MHC1. If you're destroying it, it's got to be on the MHC1 because you're done. Remember MHC2, I will help you. MHC1, you're done. Have a good weekend. No sex, no drugs, no alcohol. Come on, something I don't want to say out loud. Have a good weekend. Make good choices. I'm proud of you. Don't stay up too late.